Yes. So I think maybe right now we just in the last few minutes we have, I want to talk about industry because
Yeah.
I'm clueless when it comes to like um, engineering. How does that process work? Because so at Haverford we have Harvard College and then we have the 4+1 program that a lot of people go into. But a lot of people go into the mindset thinking that, oh, Penn has a lot of resources, I'll network when I get to Penn, and then everything will sort itself out.
So you've identified a big problem, and that is that people think their future is elsewhere, else when. And the more you wait, the more you wait. That's not how it works. You have to understand that your future is now. It's this conversation is the habit of mind and work that you carry with you. There's no such thing as pre-engineering. There is no such thing as pre-engineering. If you want to be engaged in the kinds of things that lead to those companies, be engaged now. Now, physics is this set of formalisms that underlies every single bit of engineering, every single bit, bar none. It is the formalisms of how things work. Be fully engaged in what that is. It makes you highly adaptable as new opportunities emerge.
Right.
It makes you a generalist who sees the connections across different kinds of things. It makes you a better engineer. But if you start thinking engineering is elsewhere, else when, you stop in your tracks, and that's not good.
Okay, so suppose that you are a freshman engineer or a sophomore person who's aspiring to be an engineer. By the way, there are no engineering classes at Haverford. Um,
You're wrong. Every physics class is an engineering class. It's not called that.
okay.
Again, there is no such thing as any kind of engineering where the formalisms of how stuff work is not physics. That does not exist. I am a senior member of IEEE, the Institute of Electrical and Electronic Engineers. I am a fellow of the SPIE, which is essentially the International Organization of Optical Engineers, and so on. That's all electronics over there. That book there is the most highly used reference in electronics. It was written by Paul Horowitz, who taught me electronics. And guess what?
Wow.
He's a physicist. If you look at a lot of those books, they're written by physicists. If you look up there, that's written about things getting hot and getting things cold. That changes all their properties. You can't do engineering without paying attention. Every one of those books was written by a physicist. All of these books are about lasers. Guess what? They're all written by physicists. And, well, I wrote some of them.
Wow.
If you look over there, you've got mechanical engineering. But again, a lot of that stuff comes down to what? You know it, physics. All of this is engineering materials, physics. Over there is microwaves, is radio waves, physics.
Right.
It's all held together by one formalism, quantum physics. There's no part of engineering that is not.
But what would you say to the argument that engineering is more applied and physics goes too deep into the math?
There is no engineer who can do their job without math. First, the physics people will end up with better applied math than a traditional engineer. They will end up more highly adaptable. They will see more connections. Our mechanical engineers get their jobs because they know about lasers, and a normal mechanical engineer doesn't. They outperform traditionally educated engineers. Full stop.
So if you are someone who's interested in engineering in Haverford in freshman year or sophomore year, what would
Take
you
physics.
recommend they do? Take physics.
Physics and math, there are three recommendations. The first is every single term you level up on the formalisms of how things work.
Okay.
And by formalisms, yeah, that includes math and it includes also using computers every term in ways that are new to you. That doesn't mean you need a CS class every term, but take whatever you want. The third thing is every single term you need to be putting together systems that might not work the first time. That's not using somebody else's technology. You're not a consumer saying, I will turn this on. No, that's not it. You have to be understanding again that a high school student starts out developmentally frustrated very quickly. And
Mm,
you want to get to this point where it's your game, where you enjoy, where there is joy in figuring out how to make things work.
right.
And that comes from being in an environment like a bunch of physicists. So that's it. That's your three-legged stool. A stool needs three legs at minimum in order to be stable. Formalisms of how things work. That's physics. Use computers in new ways every term. Put things together that might not work the first time and find the joy in the process. That's it.
Elaborate on the third point. What do you mean?
Okay. So, if you go, say, to Walter Smith, I want to build this widget. I want to, I have an application, an interest. There was a project I saw, and I want to start with something that would be relevant to that. I want to put together this thing. So I mentioned the bioprinting. I had two first year students come to me and say they want to do that, and they're doing it. So I gave them things. They've hacked stuff together. Some things didn't work. We're having fun with it.
Right.
They've moved on. They've made a lot of progress, and we celebrate. We celebrate every step along the way, and they're becoming unstoppable. But another first year student instead says, I want to help these people in Haiti. Their only way of sustaining themselves has to do with melting down litter, plastics, and they're doing themselves all sorts of harm.
Right.
And so I say, okay, fine, we can work on improving that in partnership with them. What is it you want to learn? And they wanted to learn programming and electronics. And so, okay, we're working on sensors and we're working on data logging and we're programming and they're learning all these things and they're having fun.
Right.
I have no idea. So, what I like about my job is that I have no idea what students will throw at me.
Mm.
My job is like improvisational comedy. People come to me with some scenario, some idea, some crazy interest. And my job is to connect the dots. Sometimes that means, oh, you need to be talking to this professor upstairs. Sometimes it's, hey, let's call up this person in Vienna. But it's fun.